In this problem, we're looking at how to use Taylor polynomials to decide on the convergence and divergence of an improper integral. This is again one of just little uh, uh, applications, one of these applications of Taylor polynomials to do a lot of things like limit, etc., etc. So the improper integral in question here is the integral from 0 pi over 2 1 over 1 minus cosine of x squared dx. So first, let us study this improper integral to see, for example, where are the bad point and so on and so forth. So here, the bad points are where the bottom is equal to 0. So we want cosine of x0 to be equal to 0. So we have x squared is equal to 0. Cosine of x squared equal to 1. Therefore, see, these are the bad points. So the bad points are where the bottom is equal to 0, which implies cosine of x squared equals to 1, which tells me that x squared is equal to 0, and we can take 2 pi minus 2 pi, etc. Keep in mind that we are taking x between 0 and pi over 2, therefore there is only one root between 0 and pi over 2 is x squared equals 0 or x equal 0. So the only bad point here that concerns us in this interval 0 pi over 2 is 0. So that's the bad point here. Okay, we can use, of course, the definition that says 0 to pi over 2, 1 over 1 minus cosine of x squared dx is equal to the limit when a goes to 0 plus, from the right, the integral from a to pi over 2, 1 over 1 minus cosine of x squared. This is possible, but this will only work if we know how to integrate this function. Then, of course, we can find, because these are proper integrals, and we can find the integral, and then we can find the limit. The problem is we can't. This function cannot be integrated. This is one of these functions that you can't integrate. So this definition will not work. Okay? So now we have to use tests of convergence. Okay? Tests of convergence. So the best one is here in this case is the limit test. In other words, we're taking x near 0, and we are going to approximate the function 1 over 1 minus cosine of x squared. And for that, we're going to use Taylor polynomial at 0. That's where it gets there. So here, first of all, we go to cosine of x. We know that cosine of x is 1 minus x squared over 2 factorial x 4 over 4 factorial, etc. So cosine of x squared would be 1 minus x4 over 2 factorial, x squared to the fourth x8 over 4 factorial, etc. And 1 minus cosine of x squared is going to be 1 minus 1, 0, minus plus x4 over 2 factorial, etc. So you see when x is close to 0, we keep just the first term. So when x is close to 0, 1 minus cosine of x squared is near x to the power 4 over 2 factorial, which is 2. So 1 over 1 minus cosine of x squared will be close to 1 over x to the power 4 over 2, or 2 over x to the power 4. So everything is positive, so we can use the limit test. We know that 0 to pi over 2 of 2 over x to the power 4 dx is equal to 2. 0 to pi over 2, 1 over x to the power 4 dx. And now we can invoke the p-test, and we know that this one is divergent because 4 is bigger than 1 at 0 by the p-test. So if this one is divergent by the p-test, the original one will be from 0 to pi over 2, 1 over 1 minus cosine of x squared dx is divergent by the limit test.